In this demo, we've created a configuration file which, when we start the SoftHub daemon on the Raspberry Pi, will initiate a Bluetooth connection on the NXP Rapid IoT multi-sensor and set the LED on the front of the sensor to green once a connection has been established. It will then enable notifications for the tap count characteristic and count the number of taps it receives. Whenever it receives 3 taps with no more than 1 second between taps, it will disable further tap notifications, turn the front LED to red, and initiate a read of the current temperature characteristic from the sensor. When it receives the temperature value, it will forward that raw packet data over a TLS encrypted connection to a remote AWS server where the packet will be decoded and displayed in an XML format. 5 seconds after initiating the temperature read, the SoftHub will set the front LED back to green and re-enable notifications for the tap count input. Lastly, when we stop the SoftHub daemon, we'll turn the front LED off and disconnect from the sensor. For the demo, we have remotely logged into both a Raspberry Pi Zero acting as our SoftHub device and an AWS server that will be receiving and displaying the raw temperature packets. So let's start the SoftHub daemon and wait for the NXP sensor to connect. We'll zoom into the PC screen so you can see what we're doing as we go. The sensor's LED is green now, so we're connected and waiting for any tap input. We'll switch over to our AWS session so you can see as the packet data arrives and is decoded. You'll notice we've started the packet capture service in debug mode, so it will print out each packet to the screen. Now we'll give the sensor 3 quick taps, and as you can see, the LED immediately turns red and we receive the first temperature packet at the AWS server. After 5 seconds, the LED returns to green and we're again waiting for any tap input. But let's pause the video briefly and review the packet contents. Each packet includes a header consisting of a unique device ID indicating which SoftHub device sent the packet, timestamps indicating when the packet was created as well as when it was received, and a sequence number indicating the count of packets received by the hub from this sensor. Notice the sequence number starts with 3 here, as we've discarded the 3 previous tap count packets we received. The packet type indicates the general type of the sensor that generated the packet, in this case a Bluetooth low energy sensor. The packet header is followed by the packet contents, which in this case includes the specific type of sensor the packet came from, the unique MAC address for the sensor, followed by any data fields being reported. Here we have the field named temperature Celsius reporting the value of 25.819. Since the raw data is reported as a float type, the raw bytes are also provided in hex so that no significant digits are lost when we convert the value to a string. So let's get back to our live demo. Now we'll tap the sensor several times with more than 1 second between taps. As you can see, nothing happens. We tap it rapidly again and another temperature packet gets reported. You can also see that tapping the sensor when the LED is red has no effect since we've disabled the tap count notifications during that time. Now let's switch back to our Raspberry Pi SSH session and stop the SoftHub daemon. As previously mentioned, when we stop the daemon, the application turns the LED off and disconnects from the sensor. That wraps up the live demo. In part 2, we'll give a quick overview of what went into creating the configuration file for the demonstration. Thanks for watching.